Hello everyone, my name is Daniel and I'm a programmer and an artist, and today I want to make a video about my Curve Sweep node because I just updated it. But before I do that, I wanted to show this new node that I added to the TerraNodes project, and it's called Pretty Crop, and what it does is it allows you to make rectangular terrains now, if you want to do that, and you can also make the corners of it rounded, or you can make it a complete circle or oval. I'm planning to make a separate video about this node and what you might want to do with it, but I just wanted to let everyone know that I added it that it's a new node and it's been added to the TerraNodes thing. Anyway, the other day I was working on this project, which is potentially going to be a chimney generator for the build part of the geometry node assets. And when I was doing that, I tried to use my Curve Solidify modifier to add this trim piece around the top of the chimney. But as you can see, the UVs are really stretched weird. And that's because the points of the curve are really close together on these bevels, and then there's a whole long segment between the corners. And for some reason, that's causing the UVs to stretch, which it shouldn't be doing. And I don't know if that's because something changed in Blender, or if I just made that Curve Solidify modifier badly in the first place and never checked this case where you don't have an even distribution between your points. Anyway, I have now remade the Curve Sweep modifier, and I thought we'd go through how to do that today. Alright, so I've just set the scene up a little bit. I have added a curve here to use as our profile curve, and a curve that we're going to sweep that profile along. And then on that, I've just added a modifier to set the material. And then a new empty geometry nodes set up that we'll build our sweep curve node group in. Now, first thing we want to do is we just want an object info, and we want to expose that to the input so that we can get our profile curve in here. And then the basic thing we're doing is just we're converting our input curve geometry to a mesh, using curve to mesh, and we're using this as the profile curve. However, as you can see, there's some problems with it. The main one is that the texture is all messed up, and that's because it doesn't have UV coordinates. So we need to create UV coordinates, and we also want to add some other useful settings so that we can configure the curve how we want it. The first one we might want to do is just add a radius. So we'll just add a new input here. That's a float. It can be a distance float, and we'll call it radius. And then we can add an input here, and we can plug this into a transform geometry node, and we can take the radius into the scale. And if we plug that into our profile curve, the default radius should be like 0.1 or something, and it can go from 0 to infinity. I mean, infinity is kind of crazy. You could set it to like 10,000 or something, I guess. So then if we set this to 0.1, we can see we can scale the size of the curve overall using this radius value. So that's a useful setting. Another useful setting would be to just expose this fill caps to the input, because you might want to choose whether that happens or not. We'll turn it off for right now, because we're going to have to do special UV things for that. Then the main thing we want to do is capture UVs on it. The way we're going to do that is using the length the length parameter on the spline, and we're going to use if we look back here, we have this curve. We're going to use the length parameter on this curve as the U coordinate, and the length parameter of this curve as the V coordinate. So to do that, we need to capture 4 different attributes. Easiest way to do that, I think, is to do 2 capture attribute nodes. The first one can be a vector, and we can use combine XYZ to get 3 values in that. And then the second one can be an integer, because we want to capture the total number of points in each spline on that. You could do this as 4 capture attribute nodes, and these could be floats, but I feel like this ends up being tidier. Then what we want to do is we want the factor, the spline parameter factor, and we want the spline parameter length, and then we want the length of the curve length, the length of the spline length, and we want this point count, which can go into the integer one. And then if we store a named attribute with the name UV map, we're going to expose this name to the input, and we can call this the UV name and put it up here, put that up there. Radius can be a single value. This store named attribute should be a 2D vector on the face corner. And then if we add a named attribute to get it, we can plug this in here, and this should be a vector, and we can view it on this. It's black for now because we're setting it to 0. Instead, we can do a combine XYZ. And then if we do a separate XYZ, now on our generated mesh, we have access to all of the curve parameters that we captured. So if we look at X, we will see we have the factor. But we can't just use this directly because, as you can see, there's sort of a gradient in both directions here. And if we were to use that as our UV coordinate, there wouldn't be a seam. You'd have an entirely squished version of the texture in on this row of faces, loop of faces. So somehow we need to convert this to a UV coordinate where there's a hard seam right here. And we can do that by evaluating the factor on the faces. Now, before we do that, we do need to do one other thing. Let me get rid of this annotation. Currently, all these curves are control points, and then it's evaluated into this final curve that you see. So if you were to capture attributes on the points, it would capture 4 attributes on these 4 points, not the actual attributes we want on the evaluated points. So to solve that problem, we need to resample the curve, and we want to resample to evaluated. And we need to do that both on our curve and our profile curve. And we can just do that. Move this over, put this in here. Another thing we might want to do just while we're here is make it easy to use this in another geometry node setup. And so we could add a geometry here, and if you'd say or curve, and we could just join this to our object geometry. And then whether they were using geometry plugged into this node in another node tree, or if they added it as a modifier and they wanted to select an object, both of those options work. And I mean, you could use both as well, I guess. I don't know why you would do that, but that just adds some flexibility to it. All right, now that we've evaluated the curve, so it actually has the final number of points, if we look again at our UV coordinates, you can see it's a little brighter over here than it was before. Let me make some more room here. If we evaluate this factor on the face, so evaluate on domain of the face, it will turn into this sort of pixel art looking thing where each face gets a solid block of color. Then if we divide the number of points in our profile curve, or divide 1 by the number of points in our profile curve, we can say, is the value on this face greater than that value? And that will give us this, where that first face is black and the rest of them are white. Then we could also say, is x equal to 0 on the point? And that'll give us this, where it's true only right here. And then we could say, on which faces are both of these true? So we could do an and. If we plug that in, we get this, where you get a hard seam right at the beginning. And we can use that as a mask on our face corners to switch between 2 values. So let's plug this y into a switch. So y is the spline parameter length, which goes from 0 up to the length going around like this. We want to plug that into the false value, and then we'll switch that. So now you can see we have that everywhere. And then if we take the total length of the curve, which was that constant value, and is in the z coordinate, we can plug that into true, which will replace that one row of face corners that's at the very end with the total length value. And that will create the UV seam that we need at the beginning of the curve. Now, one other thing we might want to be able to do is scale the u-coordinate based on the radius of the input curve. And if we're going to do that and we want to have the radius be able to vary, or that scale vary across the curve where different points have larger or smaller radiuses, we will get distortion on the texture, and because it's scaled and stretching. Now what we can do to minimize the stretching is offset the entire UV island by half of the length of that profile curve, so that 0 is at the center of the UV island instead of being at the bottom. And that way when you scale by the radius, the amount of distortion is distributed on either side rather than being all at the one end of the UV space. And so to do that, what we want to do is add a subtract node, and we want to subtract through a switch, because we only want to do this on the u-coordinate. We're going to make a group out of this. Then we want to take this z total length of our curve and multiply it by 0.5, and we'll plug that 0.5 value into true on this switch. Then if we want to select this whole group, including the capture attribute node, we can make a group, and we can expose this switch value to the input. We'll call this center, and we'll call the output coordinate. And we can call the group curve coordinate. So on this one, we want to center it. Then we can make a copy of it and plug it in here, and we don't want to center it on this one. But then if we combine this as the x and this is the y, or vice versa, you can see we now have UV coordinates on a curve. Now on our profile curve, we want to multiply by the radius of the control curve. And so to do that, we need to capture the radius. So let's add another capture attribute node here. And we're going to capture the radius. And if we plug that into here, you can see we get this, where the size of the texture on the larger radius is the same as it is over here where the radius is smaller. However, we might not always want to do that. So to do that, we could make a switch here. And we could plug the switch into the input. And we could call it UV use radius. And then for the false value on that, we probably still want to use the radius just so that we can scale the whole curve up and have it use that. So let's just accumulate the field. I want to group this by an index. And we want to evaluate that index on the domain of the spline. And we want a copy of that. We can capture an integer. We just want to capture 1. If we then divide the sum, the total sum of all of the radiuses on the spline by the number of points in the spline, we can get an average radius and use that constant value on the curve. So that way, if you scale this up, this texture scale stays kind of the same. But you could have another curve that was bigger, like so. Now this use UV radius should be a single value, and then we should probably add as well, after we've combined the XYZ, we should put that in a scale node, and we should just add scale to the input, and we will call this, again, this should be a single value, and we'll call it UV scale. So now we have the control, we can change the size overall. All right, we can just check too, if we make this curve cyclic, that still works, which it looks like it does. Just move that over there. We also need to solve the problem of fill caps. So if we turn that on now, you can see it fills the cap, but the texture is messed up. So to fix that, we need to identify where these caps are. So we're going to want to switch between our UV coordinates. we're going to need to capture some attributes on our curve again. So we want to capture a Boolean value. And the value I want to capture is if it's an endpoint selection, and if the curve is cyclic. But we want to know if it's not cyclic. So if I just plug this in here, I'll show you why that is. So if we just take the endpoints, we still get that even if the curve is cyclic like this. So, but in this case, we don't have caps filled, and we don't want to replace the UVs here because it's cyclic. So if it's not cyclic, we use the endpoints. Otherwise, we don't use anything. All right, so I was going to add a random thing, and I turned this curve lines across on. However, that messed all the UVs up and revealed a new problem I hadn't thought about. So the problem is that this curve lines across takes our input curve and it puts lines across it. And the lines are curves, but they just have 2 points. And the problem with that is when we do this and on the is cyclic and the endpoint selection, it's not cyclic, so that's true. And we select both endpoints. So the entire mesh gets selected. We can see that if we view it here. And if we view the mesh, the entire thing's white because it's selected. So instead of doing that, and the problem with that is it selects the, so if we were to add another point in here, can I subdivide the curve? So if we were to add another point in the middle, then you can see the middle is not selected, which means that if you evaluate the point on the face as a Boolean, you only get the ends because the middle actually averages out to like 0.5 or something. However, because there's only 2 points, the whole thing's selected, and so it unwraps in the middle. So I think what we actually need to do is we need to combine this into an XYZ, evaluate only the start point, and then also evaluate only the end point as 2 separate values. We'll evaluate this as a vector, or capture it as a vector instead. And then we can separate XYZ. Now I have X. We're going to evaluate this on the domain of the face. So it's this. And then we can say is, I guess, equals 1. Get rid of this. So we want another one of those here. X equals 1, Y equals 1. And we want to AND those together after. Oh, we want OR, not AND. Then we need to create the actual UVs for this. So in this true socket, where we have 0 right now, we can just use a UV unwrap. And for the selection, we can just use the same value again. So now we've UV unwrapped that. But we have a problem, which is that the scale doesn't match necessarily the scale of the rest of the UVs. So in order to do that, we want to split the faces, or split edges rather, on this mesh, and we want to do a set position. And we want to set it to the UV coordinates, and then we want to sample an index from the face. And we want to sample the area, face area, and we want the index to be the index of the face. So the face index, we split the faces and move them to the UV coordinates, which looks like this. But then we want to sample the same face that we are in the original position here, and check the face area now that we've moved to the UV coordinates and compare it to the face area originally. So if we divide this UV face area by the actual face area, and then we take the square root of that because the area is squared, then we can scale. Again, we want to evaluate on the domain of the face, I think, and then we can scale our UVs by this value here. Oops, move this over. Let's see. So I think I've got this backward. I think I actually want to divide the original area by the UV area. Yeah. And now the UV scale on the end caps matches the UV scale on the rest of this. All right, so that does it for the end caps. The only other thing we might want to do is to be able to add a random offset on each curve. So say, for example, you did lines across your curves like this. And yeah. So then if we turn off fill caps, it still works. All right, anyway, I was saying, currently all of these lines, they go across our curve. The texture starts at exactly the same place. So we see this part of the texture repeated on every single one. So something you might want to do if you're using something like this is randomize each curve's UVs slightly. So after we've got our UVs here, we can just add vector math add we can put this in an input, and we could call this UV random. And that should be a single value. And we can make it 1 and 1. But we don't add it here. We actually want to capture it on all of our curves. So let's go all the way back. We want the UV random to go into a random value as the max. And we want the ID to be the index evaluated on the domain of the spline. And then we want to capture that attribute on the points. And then we can move that down here. Let's put it up here. And then plug it in to our add. So then we get different parts of the texture on each of our curves. So if we set the y to 0, it only changes on the x-axis, like so. Or if we set x to 0, then we can only shift it randomly on the y-axis, so on. And I think that about does it for the Curve Sweep node. Now I got to go add that fix for the endpoints on the caps to the actual file. So anyway, I hope that was interesting and informative, and hopefully an improved version of the Curve Solidify video that I did. I think I've learned a few tricks since then. So anyway, I just wanted to show that, and that I've updated that, as well as updating the TerraNode with this new node. And yeah, that's all I've got for this one. Thanks for watching.